Class 11th Chemistry, Unit 8 Redox reactions, and in this video we will discuss about oxidation and reduction in terms of electron transfer. First, what is oxidation? Oxidation is the loss of electron by any species, and reduction, this is the gain of electron by any species. For example, sodium when reacts with the chlorine, it will convert into NaCl. Now what happens in this reaction? Sodium lose electron and chlorine gain electron. Okay, so we can say sodium is oxidized and chlorine is reduced. And actually this whole reaction can be split into two half reactions, and these half reactions are these. Sodium convert into Na plus by losing electron. Each sodium atom lose one electron. Okay, now Cl2 is a molecule and it is comprises of two chlorine atoms. So we can say each chlorine atom gain one electron to convert into Cl minus. This is oxidation half reaction and this is reduction half reaction. So we can say half reactions that involve loss of electrons are called oxidation half reactions or simply oxidation reactions. Similarly, the half reactions that involve gain of electrons are called reduction half reactions or reduction reactions. Okay. Now take some more examples. Sodium when react with the oxygen, it will convert into sodium oxide. Now in this case, sodium lose electron, so sodium is oxidized, and oxygen gain electron, so oxygen is reduced. One more example, sodium when react with the sulfur, this will convert into sodium sulfide Na2S. Now again in this case sodium lost the electron, so sodium is oxidized, and sulfur gain the electron, so it is reduced. Okay. Now again when sodium lost the electron, okay, oxygen is gaining this electron. If oxygen is not there, then sodium is not able to lose the electron. So we can say oxygen is responsible for the oxidation of sodium. Okay, such species which oxidizes others is known as oxidizing agent, and itself it reduced by accepting electron. So we can define oxidizing agent as species which oxidizes other and get reduces itself, or we can say that oxidizing agent is acceptor of electron. In the same way, oxygen is reduced. Why it is reduced? Because it gained the electron. Who is supplying this electron? Sodium is supplying the electron. So we can say sodium is responsible for the reduction of oxygen. So sodium is a reducing agent. Okay. So we can define reducing agent as species which reduces other and get oxidizes itself is a reducing agent. And in simple way we can say donor of electron is a reducing agent. Oxidizing agent is also known as oxidant. Clear? And reducing agent is also known as a reductant. Now I think it should be clear. If we define what is oxidation, so we can say oxidation is the loss of electron, and the species which is oxidized, that is known as a reducing agent. This is a reducing agent. The same way, what is a reduction? We can say reduction is the gain of electron. This is gain of electron, and this is known as oxidizing agent or oxidant. सिंपल वे, जिसका ऑक्सीडेशन होता है उसको बोलेंगे रिड्यूसिंग एजेंट, और जिसका रिडक्शन होता है उसको बोलेंगे आप ऑक्सीडाइजिंग एजेंट. नाउ प्रॉब्लम 8.2, जस्टिफाई दैट द रिएक्शन 2Na plus H2 converting into 2NaH is a redox change. Now this reaction can be split into two half reaction. First one is 2Na converting into 2Na plus 2 electron, and other half reaction is H2 plus 2 electron converting into 2H minus. Now in this case sodium is oxidized. Why? Because loss of electron is there. And hydrogen is reduced because gain of electron is there. Therefore, complete reaction is a redox change. Okay. Now, competitive electron transfer reactions. Place a strip of metallic zinc in an aqueous solution of copper nitrate for about 1 hour and observe what will happen. Strip becomes coated with the reddish metallic copper and the blue color of the solution disappears. This can be expressed in this diagram. This is copper nitrate solution which is blue in color, and this is a zinc rod. This is initial stage. As the time passes, intensity of blue color is reduced. So this is intermediate stage. And finally, Cu2 plus is deposited as Cu and blue color of the solution disappears. Okay. Now in this case, copper, that is Zn2 plus is formed. Zn2 plus is formed. Actually, zinc displaces copper from the copper nitrate solution and convert into Zn2 plus ion. And how can we confirm the presence of Zn2 plus ion in this solution? Formation of Zn2 plus ions can be verified by passing hydrogen sulfide gas through the colorless solution containing Zn2 plus ions. Then a white precipitate of zinc sulfide is formed. Zinc sulfide, ZNS, on making the solution alkaline with ammonia. It means first we will add the ammonia in this solution to make it alkaline. Then if we pass the H2S gas, then if we get the white precipitate of zinc sulfide, it confirms that Zn2 plus ion are present in this solution. And the whole reaction can be represented this Zn plus Cu2 plus converting into Zn2 plus Cu. In the lower classes we have discussed this is one of the example of displacement reaction. More reactive metal displaces less reactive metal from its salt solution. Now, in this reaction, Zn converting into Zn2 plus by losing electron. Okay. And Cu2 plus is converting into Cu by gaining electron. So we can say zinc has lost electron to form Zn2 plus, therefore zinc is oxidized. And copper ion is reduced by gaining electrons from the zinc. Now, in the same experiment, finally, we will get the zinc sulfate solution. Now, in that container, place a strip of metallic copper in zinc sulfate solution. And again observe, there is no visible reaction is noticed. It means that its copper does not displaces zinc from zinc sulfate solution. If this displacement reaction is taking place, then copper ion should be present in that solution. But again, we can verify that the copper ions are present or not. So we can say presence of Cu2 plus ion cannot detected by passing H2S gas through the solution to produce the black color of cupric sulfide. It is again, if we pass the H2S gas in that container, we will not get the black color precipitate of copper sulfide. It indicates that reaction does not take place. Okay. So we can conclude state of equilibrium for the above reaction greatly favors the products over the reactant. What does it mean? It is zinc displaces copper from copper sulfate solution, but copper does not displace zinc from zinc sulfate solution. Now again one more activity. Now place copper metal in aqueous solution of silver nitrate. Again observe what will happen. The solution develops blue color due to the formation of Cu2 plus ions. This can be expressed with the help of this diagram. This is a silver nitrate solution which is colorless, and this is copper rod. When reaction proceeds, blue color starts developing, and finally intensity of blue color increases and silver deposits on the rod. Now in this reaction, copper being more reactive than silver, copper displaces silver from silver nitrate solution. Okay, and this reaction can be represented like this: Cu plus 2Ag plus converting into Cu2 plus 2Ag. In this case, copper released 2 electron and each Ag plus ion gained 1 electron. When 2 electrons are loose, 2 electrons should be gained. So we balance the reaction by putting 2 here. So we can say copper is oxidized to Cu2 plus and Ag plus is reduced to Ag. And again, equilibrium greatly favors the product Cu2 plus and Ag. If we compare these two experiments, then we can conclude zinc releases electrons to copper and copper releases electrons to silver. And therefore, the electron releasing tendency of the metals is in order. That is, zinc is most reactive metal among these three. Okay, and silver is the least reactive metal. And actually, this is called activity series or electrochemical series. Okay, more detail of electrochemical series we will discuss in class 12th. Thank you.